Problem number 11, we have a graph. All right, and they just have a picture of the graph. And right at x equals 3, there looks like there's a vertical asymptote. In other words, x can't equal 3. All right, and we'll talk about that in a second. But they have a graph that kind of does one of these deals. It goes like this, and it goes like that. And they ask a bunch of questions like, what's the limit of this thing? So I'm going to do 11, 12, and 13 and 14, even though it hasn't been assigned, because it's a good way to kind of cement in your mind what we're talking about when we do limits. So problem number 11 says, hey, what is the limit of f of x, which is the graph, as x approaches 3, and it's from the negative side. All right, so just to kind of recap. When they ask us what's the limit of something like this, when they ask us that, I'm supposed to write in this box, what is the y value approaching? Now here's where it gets confusing. As x approaches one value, the y value approaches a value as well. So when we say the limit, we're not talking about what the value is, but what we think it's approaching. We're talking about behaviors, all right? So what I'm really saying, oops, I forgot my little negative sign here. Just put that right there. When I do that, I'm saying as we go across the x-axis towards the number 3, this little sign here means from negative infinity on the x-axis. So this is negative infinity and this is positive infinity. In other words, when you see that little negative sign, you could think to yourself, from the left. All right, now what that means is I'm going to follow the curve from the left, and I'm going to try to determine what my y value will be as x approaches 3. Well, as we get closer and closer to 3, what does my y value look like it approaches? Well, here's the interesting thing. My y-axis has positive infinity and negative infinity. So the answer is positive infinity for this limit. That's problem number 11. I'm going to do number 12 and 13 as well, and 14, because it's just good to do it that way. So now, if I were to say to you, what is the limit of f of x as x approaches 3 from the positive side, I could think from the right. Because what we're really saying is look at the x values as we come from positive infinity. Gotcha. So I'm going to come along like this, and I'm going to, now, but remember, what am I asking? As x approaches 3 from positive infinity, what is my y value approaching?
Negative infinity.
Negative infinity. Good. Now, this is something you kind of have to get used to. But there's two types on these rational functions. There's two types of behaviors that we want to look at. We want to look at first, what is the behavior as we approach a vertical asymptote? And the other is what we call end behavior. So now end behavior is a unique beast. But end behavior is when we look at the limit of a function as x approaches infinity. Now this is where it might be confusing, because what are we looking at? We're looking at the curve going this way as x approaches positive infinity. What does that look like it would be approaching? Well, we don't know for sure, but it looks like there is a horizontal asymptote at 0, and as somebody already said, it looks like it's approaching 0.
So basically for end behavior, you're just taking the y value from the other one and putting it there?
Yeah, but you gotta think as x approaches some number. Mm-hmm. So this part right here lets us know what direction to look along the curve. And so we're looking along the x-axis trying to trying to determine what the y values would be. So now if I were to say to you guys, all right, that's cool, let's do one more. What's the limit of f of x as x approaches negative infinity? Well, what we're going to do is we're going to come now this way and go towards infinity, and what do you think that value is?
0.
0. So rational functions, the interesting thing about, and when I say rational functions, what I'm really saying is when you have fractions as functions, there's a couple of characteristics. They have a tendency to have at least one vertical asymptote because that means there's a 0 in the denominator. Now the horizontal asymptote is based on the reduction of the degrees of the rational functions, and we'll talk about that. Problem number 45 is a great example of that.
So could you put the limit of f of x as x approaches positive infinity? Could you set that, like, could you put that equal to the other one that's negative infinity because they both equal 0? Like,
In calculus we will do that, but they're two. You can only set them equal if x is approaching the same from the left and right. Okay, so her question is, it's a great question. Let me clarify that. Let's say, for example, all right, my limit of f of x, and this is a completely new problem, but this is going to kind of answer her question. I have a removable discontinuity at x equals 2, right? But that removable discontinuity is approaching 3 for the y value. In other words, this open hole is at the coordinate point 2, 3.
Yes.
Okay? It's not defined there, but that's what we need to be thinking. So I say, all right, well, what's the limit of this as x approaches 2 from the negative side? Well, I come in and I come in and I come in. What does it look like it's approaching? 3. Well, now, if I take the limit of f of x as x approaches 2 from positive infinity, or from the positive side, I'm going to come from this side. What does it look like it's approaching? 3. If my left-sided limit, this whole thing, is equal to my right-sided limit, in other words, if I have the limit of f of x as x approaches 2 from negative infinity is equal to my limit of f of x as x approaches 2 from positive infinity, then we would say that the limit, the overall limit of the function as x approaches 2, notice I don't determine what side we're approaching from, it's the same. In this case, it would be 3. We'll do a lot more of this towards the end of the school year. Okay, but it's good that we talk about it now, because rational functions have some interesting behavior. Okay, but to answer your question, x is approaching the same value on all 3.
Just different directions.
Just different directions. Yep. And this is the only time we can say it. If I change this to a different number, then it's just a coincidence. Does that make sense?